this investigation actually, but basically the designing of cam or construction of cam profile. All right. So we have another example here. So this example, the these steps are same, right? So you got the profile 90-degree lift or the outward, and we got 30 12 60 cam return, and then 12 of remaining angle 120. So you need to draw cam profile for both, for two categories. And the important thing here, so we follower is a knife edge follower, that you need to be careful with this one. And then if the line of the stroke of follower passes through the axis, the simple one, and then if you have an offset of 20 millimeter. So this part is same, so I will briefly go over that, but you will have some additional problem to investigate. So it says that radius of the base circle of the cam is 40 mm. Determine the maximum velocity and acceleration of the follower during its ascent and descent. Ascent means it's outward and descent means return. So if the cam rotates at 240 rpm, so we have done some formulas, so we will use those information to find out this content. Right, so first case, the very first step is to generate this diagram. I have shown you through the video how to generate. So you see this is a 90-degree and this is 60-degree. So this problem is of further good interest because we got 90-degree for the outward and different angle 60 for the return. And then we have a 12 for 30 and then 80, 180-degree. So you choose the scale, you make this x-axis 360 complete revolution, and then this is the 40 mm, and you make a rectangle. So this rectangle basically, so this whole rectangle is required. Then you draw this semicircle as explained in the video, and you divide in equal parts. So if you divide in, this one is 6, so this is also 6, and then you draw these lines to find out the point, right? Yeah, so you draw this, so you can keep consistent nomenclature the way you like. And so this is 6. Even we are covering just 60-degree angle for the return, we still keep the same deviance. This is important, you need the same deviance as well to make your life easy. So this is the follower displacement diagram, and then we have a the cam profile. So the both are just given here because the process is exactly same as we have done. So if you look carefully, what we have, when it passes, the knife edge follower passes through this one. So you make 90-degree, you make 30-degree dwell and return 60-degree. For 90-degree, you divide in equal number of parts as we have done, and then you mark this point 1B, which you find from here, for example, and 2C, and then this one 2D. So you mark these ones, and then you connect those ones basically. Of course, you have to do for the dwell. You don't need any deviant for dwell, and you have the return as well. So that's the portion you connect actually. So this was a simple one. When you have offset, so in offset you need to be very careful. You need to plot another circle here of the offset distance. So this is 20 mm, and then the knife edge follower has to passes through 20 mm. So it just touches this axis over here. So then you locate point A. So the point A is basically the reference point. This point A, this, when then you mark this angle, and then you, let's say you have 60-degree, and then you just like make same deviance within this angle. So from here to here 90-degree, you divide in equal parts. So you say 1 2 3 4 5, and then each line you extend and pass through this point, and as well as tangent to the offset circle. For example, this fourth line, you draw it, you extend beyond the base circle. So this is the base circle, and beyond the base circle and tangent to the offset circle. And then just matter of just finding this distance 4D, for example, or 3D basically. So this distance comes from over here, right? And then you just freehand, you connect those points. So you see, because it has a different angle for forward, and return with 90 and 60. So that's why return is like different profile, and you got a return a different profile. So for outward and return, both are different profile. Then some extra work you need to do. Yeah. So that the different things what we need to do is basically we have been given. So we have been given the stroke 40 mm, then outward angle, which you are writing in, and you can work in radians as well, and return angle 60 degree. This again in radian, and n, this is 240 rpm. So revolutions per minute is also given. So from here, the very first step is to find out angular velocity, which is very simple. If something is rotates at some certain rpm, so 2 pi n over 60 is its angular speed. You find 25.14, and we also know that the maximum velocity of the follower during the ascent. So the outward velocity, we have driven this formula already. The v0 is equal to pi ws over 2 theta 0. So you find out the maximum velocity. So this equation was for maximum velocity. So this is 1 meter per second. And maximum velocity of the follower during its descent, which is a return, vr return. Same formula, is just the angle is different. And of course, yeah, so just the angle is different, basically, theta r. So you got 1.51. So this is very huge velocity. 1 meter per second and 1.51 meter per second is a big value, which now you can see from the acceleration. So the maximum acceleration equation, this was also driven within the same presentation. In the last lecture, I have given you the proof of this equation, which you can use to find out. You just matter of plugging the numbers, and you can find out what's the acceleration. So you see A0 for A outward is 50.6, which is quite big number. So the acceleration is quite high for such operations, and return is even further actually, 113.8 meters per second square. All right, then we have another problem, 20.3. So this problem is of little bit different interest because of this. So you got a roller follower rather than knife edge. So most of steps are same. The only issue will be roller follower is a little bit different aspect, which I will go through. The other steps are quite similar. So you see the information will always be given in this format. So you have the raise the valve through 50 mm during 120 outward, dwell, return, and then another dwell, and the roller diameter, because now it's a knife edge. Instead of knife edge, you have another follower with a roller edge. So different types of follower we have already discussed, so we can have a roller as well. And the diameter of camshaft is given. So you need to work out two different again. One, when the line of stroke of the valve rod passes through the axis of camshaft, as we have done before, and if you have an offset of 15 millimeter. So this is also we have done. So the only difference within this one would be the roller follower actually. And also you have to work out what's the maximum acceleration and the velocity as well when you have 100 rpm, and it's same is doing simple harmonic motion, right? So this the motion is consistent. All right, so now, yeah, so these are the parameters given. So construction of this diagram is exactly same we have done. So instead of like writing outward stroke, we are writing valve raised. Why? Because it's been asked like that. But it's up to you actually. You can write. It's the same meaning actually. So this is the same method as I explained in the previous example, and as well as the short video which I have shown you. So that's why you see this is 120, which is double than 60 for return. So you see how the profile look like when the return, and how this is in the front. So that the forward displacement diagram is exactly same. Doesn't matter if it is a roller forward or it's a knife edge follower. That's what we have done, right? So now the next is drawing the first part when the line of stroke of the valve rod passes through the axis of camshaft. So this diagram is same, so you don't need to worry. So here the only difference is we got two different things here. One, we have the base circle. So you see this line, this line is a base circle, right? So this is the base circle, that's the minimum radius which is given, which is already given. So base circle, which is 25 mm. So that's already given to you in the problem. Then you what you do, draw a prime circle with center O and radius. So now we have additional part here called as a prime circle, which is over there. This is the prime circle. So what is this circle? So this circle is actually the radius of the roller, which is the part of follower. So this is the follower, which is a roller is connected at the end of the follower. So of course you can imagine when it moves over here. So when it's moving, so the cam actually is a little farther. How farther? The half of the diameter of the roller. So this roller, so this trace point A is farther from the cam profile. If it's a knife edge, this is exactly sitting on the cam profile. But now because of this presence of roller, this will stay away throughout the profile. And how far it will stay away? This will stay away the radius of the follower. So now you draw another circle called as a prime circle, which is basically base circle plus this distance. And what is this distance? That's the radius. So OA is a minimum radius of cam plus half of dia of roller. So we got a 25 mm of the cam, and then 20 diameter was the roller, and then half of this, so you have 10. So you have 25 for the base, and 10 comes from the roller, and 35 mm. So this prime circle is of 35. So you draw a prime circle like that. So this is additional circle over here. Now the steps are more or less same. Yeah, so the steps are same now. What is it basically? Yeah, so you mark the reference from here to A, and then you got 120 degree at this point. So which this whole angle is 120 degree, right? And then you divide this with the equal number of parts you have done. So you have divided into 6 parts. You divide into 6 parts as well, right? So from here to here, it's a 6 divisions, which are now marked on a prime circle rather than base circle, but it doesn't matter because both are same circle with the origin. So this in this example is not a problem. So you mark those on a prime circle now. So draw angle 120 to represent raising of outstroke the valve, angle SOT for the dwell, and angle TOP for the represents lower. So you mark all these 120, 30, and then 60. Divide the angular displacement of the cam during raising, lowering the valve into same number of equal parts as displacement diagram. So this displacement diagram was in 6 numbers, so you divide in 6 numbers. So that's why you mark 1, 2, 3, 4, and then 0 dot, 1 dot, 2 dot, which are like this one, the return one. Join the points 1, 2 etc with the center O and produce the line beyond prime circle. So now you join these points and then draw line which is going beyond the prime circle. So you see now we are talking about prime circle all the time rather than the base circle. So draw those lines. So set off 1B, 2C, 3D curve. So you again, now the step is same. So you mark 2C, 3D and draw from here. So now with the base circle, instead of base, we have prime circle from 3 to 3D. So this distance, for example, you find it from here, from 3D, and then mark over here. So that's the point basically. and then you just join those points. So this, you see, this is the, in the dashed line is connected, which is called as a pitch curve. This time it's called as a pitch curve. From the points A, B, C and P, draw a circle of radius equal to the radius of roller. So on each point, this one from A, B, C, these points, basically you can draw a further circle like that. So of course, what is this radius? This is radius of the roller. So you draw these circles at each individual point just to show that within the pitch curve where you will have the roller, basically. So where is the roller? Is a smooth curve. This is the line required profile of the cam. Draw the circle of radius equal to radius of roller. Join the bottom of the circle. This time you join the bottom of the circle like that. So where the circle is there, the bottom, so each line, because we got a circle, so the bottom point where it's meeting this point, you connect those points basically. So this is the cam profile, right? So because you are asked to draw the cam profile, not the pitch curve. So pitch curve you draw, and then finally what you do, you draw the cam profile basically, right? So the cam profile is a physical part which is present there. So this is something that you need actually. All right. So in summary, again, I will just repeat the steps which are a little bit additional. So you have marked already the points, and then so you have AO, so you got OA and OS. So these are the lines for outward, right? And then what you do, you have already your prime circle, which is this one, and you place the same deviance, 6 deviance. Once you have 6 deviance, you connect the lines which is going away from the prime circle, right? So those lines you have drawn, and then the center point where, so you mark this distance, right? So this distance, for example, this line, so 4E, this distance you mark from here. So this 4E is this distance, and then you connect these points. This is a pitch curve. Once you have connected, then the bottom of these small circles will be the one which generate the cam profile, right? And yeah, so that's all. And next is basically the offset. So the process is exactly same, but of course you need an additional circle, which is an offset circle. You draw the offset circle. So this distance is already given, so which is the roller forward motion, and you again connect this OA to OS, and this is 120 degree, and then what you do, you mark this deviation. So this deviation, so this is on a prime circle, you mark those points, right, with the 6, and now instead of passing through the center, we pass each line tangent of the offset circle and further going on, right? Then you find out this distance which was here, for example 2C, or for example 5F. You find this distance, and this 5 distance you mark over here. Then on each circle point, this is center, so you connect it. This is called as a pitch curve, and you can draw the circle, the roller circle over here, and wherever it is the minimum point, you just connect those, which will give you the cam, right? So this is the way you will generate a cam. So this all been nicely explained in this section as well. So as you go through, I would really appreciate if you practice this couple of times, so you feel more confident if it comes up in exam. So you should be able to solve this one without any issue. So the process is similar, and it's a simple step as well. So it will be very helpful actually. And then the last step is, yeah, so you got a similar equation. Doesn't matter if you have a knife edge or roller follower. So you got an angular speed you need to work out. Then you have the maximum velocity outward, and then return velocity, acceleration outward, and return acceleration. So these things you can easily find out, of course, from the known equation, which are very simple to drive, which are explained quite in detail in this lecture. All right, thank you.